Hey guys, what's up? Have you ever wanted to be part of the cool crowd and you're not part of the cool crowd? Well, today we're going to tell you how to be part of the cool crowd. Today, let's talk driver cooling. Driver cooling is one of those areas that is oftentimes overlooked and can be the difference between winning and losing, having a good race and having a not so awesome race where maybe you get heat exhaustion, heat stroke, or worse, you go off the road and have a bad day. So today we're going to go through what we do, some of the things we've learned over the last couple of seasons of racing, and then some of the areas where we think, hey, we can make improvements there. We're going to experiment and try. I'll walk you through the process of where we're at, some ideas, the process that we go through to design and build prototypes to test. And then in the future, we'll give you a feedback on how these tests went at the track. At the end of the day, the track tells all, and we'll know if it works or not. So let's start off with the racing gear. So let's go through the gear. So on the left is real typical gear that most racers will wear. And on the right is ski gear that I use when I go skiing. You may ask yourself, well, why is he showing me ski gear? I want to give you an idea of how hot it can get in these cars under race conditions. So the inside of the car alone can get 120 degrees plus. So we race in the Southeast. You can only imagine August in Georgia with all this gear on, with a hot car, you can get pretty hot. And here's a little analogy that someone told me once, which I thought was great, which is why I showed the ski gear. To get an idea of how hot it can get, imagine putting on all your ski gear, your ski pants, a couple of layers of clothes, plus your ski jacket, plus a balaclava, plus a helmet, plus your gloves. Now get on a treadmill and run on a treadmill for upwards of an hour. And at the same time, you have other people on treadmills trying to run into you or try to get ahead of you. That's how hot this can get. And so driver cooling is absolutely critical to having a good day at the races. So I'm going to walk you through our gear, and then we'll talk a little bit more about our current setup and maybe some ideas for how we can improve that. All right, so let's walk through the gear. It's actually pretty straightforward. All the drivers wear Nomex long underwear, essentially, bottoms and tops. We race with a Cool Shirt. So Cool Shirt is a brand name, but it's like the Kleenex of cooling shirts. So essentially it's water running through tubes that run up and around and take heat off your body. We've got some ideas on how to improve this that we'll talk about in a future video. Fireproof gloves. We have fireproof boots. Nomex balaclava that we have on our head. And then our fire suit, and there's all different brands and makes and styles and thicknesses and materials, but essentially one piece zipped up. Essentially you want every part of your body covered in case there's a fire. And then our helmet. And I'll walk you through some modifications that we've already made to our helmets, and then some ideas on some things that we want to do in the future. Now let's go inside the car and take a look at what we've already done. Hey guys, we're back. So let's take a look at the inside of the car. I'll walk you through some of the things that we've already done, and then I can show you some of the areas where I think we can improve. So let's start off with the water cooling. So this was the Cool Shirt that's over there on the driver's seat that I'll show you here in a second. Essentially what it is, it's a cooler. It's got a little pump in it. It's a little bilge pump, and that pumps water in, out, and all the way around that I'll walk you through. And you fill this cooler with ice and water, and then you want to put a little like rubbing alcohol. There's some other fluids you can put in to protect it so you don't get mildew. But essentially, the pump will just pick up the cold water, pump it up, and then the hot water will return here, get cooled down, and then that system works. We've also added this little pipe that I'll walk you through here in a minute, but let's go take a look at the Cool Shirt. All right, so now we're on the driver's side. Let me show you how this all connects. So this is the Cool Shirt that I talked about in the opening scene. And this is where the pipes come out, so the hoses come out. This routes all the way to the cooler, all the way around. There's an in, and then there's a return back. And these are all just quick fits, quick fittings. So you press here and pull out, snap in. Super easy with a little O-ring right here. And then essentially the water just runs around, picks up the heat off your body, returns back, and then that goes back to the cooler to get cooled off. You can turn this off. We've got a little electric switch on our dashboard right there. You can see it kind of second from the left. And then we can turn it on and off as needed. Usually we just leave it run the whole race, but it's there if we need it. All right, guys, let's talk air cooling. We just talked water cooling with the cool shirt. Now let's walk through some of the things that we had on the car that we tried, and then some of the improvements. So one of the things we did is we added this little piece right here. So this came off another helmet. I had to adapt it to this one. But basically, we attached it via double stick tape. And if you look closely, you can see there's a hole there. There's one that you really can't see that's under here. And then there's one here that comes with the factory. And these had little vents on them, so if you had air from the outside blowing in, it would blow air in. What I wanted to do is I wanted to force air in here that would force air through those holes. So what we did at first is mounted this up, and then I took a hose and attached it here, and I'll show you where that came in. That was kind of version 1. All right, guys, let's take a look at the vent that we added last winter to bring in some air from the outside to cool us down. So this is called a nacoduct, this little piece right here. What we did is we added these polycarbonate windows on the side. We cut this out. We're going to do the same thing on the other side, maybe next winter. That'll be another future video. And then what happens is as the air comes in, the way these ducts are designed, it's very low drag, but you get a nice airflow into this guy and into that hose. And I'll show you where those go here in a second. But that was kind of version 1, and it worked okay, but we think we have some improvements to this. Okay, so let's take a look at the inside where these hoses go. So as you can see, that's hose number 1. This hose we actually attached. I found a little adapter that I kind of cut up, added this little 1.25" hose that comes down, and then I took this end, and this was attached to the top of the helmet on that black piece. And it worked okay. It actually brought in a little air, but honestly, it wasn't awesome. It cooled us down a little bit, but we thought, well, we just need more air. So that was modification number 2 that I'll walk you through. All right, let's talk about the second modification we made to get a little bit more helmet air to us. So the bottom hose, we ran down, and this time we ran it to a bilge air pump. And so that we can turn this guy on and off. And so what this did is brought air in, then this forces air in through this piece, and then this little plastic piece on the other end then attached to the helmet. This worked out quite well. So we were on to something. So then we thought, well, let's make a third modification, which I'll walk you through here in a second. All right, so let's talk about the third modification we made. So the third modification we made, we kept the hose going to the window, all the way down into the air pump. But this time we rerouted the air. We actually came in, I don't know if you can see all this spaghetti of hose, and we brought it into the bottom of this cooler, and then back out of the cooler, and then this piece attached to our helmet. This time in the cooler, we added this little U piece. So this is a hollow aluminum piece. And the thinking there is as this is all packed up with ice, this is getting nice and cold and hopefully cooling down that air. So as the air comes in from outside, gets cooled down, and then gets pushed up to our helmet. That worked out way better. But we still think that there's some improvements that I'll walk you through here in a minute. All right, guys, now that we've talked about air cooling a little bit. Talked about water cooling. Now let's talk about hydration and what we've done so far. And this has worked amazingly well. So one of the things that we do is we run this car in an endurance series called NASA Trek, and they could be upwards of 6 hours long. And so Alec and I have done double stints up to 2 hours in a hot car, and you need to hydrate. There is no doubt about it. I'm not even sure how you do one of these races without in-car hydration. And so what we had is we had a little 1 liter bottle that came with the car from the previous owner, and it worked fine, but it was nowhere near enough. And so the first thing that we did is that we went ahead and supersized it. And so we put this huge thermos in, and what this does is we can fill this thing up with gallons of water and ice, and this stays super cool the entire race. We don't ever have to worry about refilling it. We've never run out with this. And even on the sprint races, we still use it. We just put maybe 20 or 30 ounces of water in there. Works awesome. I'll show you how it's routed here in a minute. But this modification we made last year. That's golden. And we've just got it strapped down because obviously you never want this thing to be moving around, and it's solid. It's never moved on us. So let me walk you through the routing here, and then I'll show you where it goes from here all the way to the other side of the car, how it attaches, and then how it attaches into our helmet. Okay, so let's play follow the path of the water. So we fill up water. The water will go up, out, goes around, travels down this part of the roll bar and onto the other side. And I'll show you how that attaches. All right, now we're on the driver's side. So you can see where it routes in along this bottom bar. And then we've got it running up through this little printed bracket that we use. This is where our radio comes in. But the hose comes up, around, and then attaches right here to our window net. So when this comes up, it raises up to about this high. So right where we're level with our elbow, let's say. And you can connect it. It's got a little quick disconnect on it as well. You just press this little button, you snap it in, press the button, pulls right out, works like a charm. So I'll show you how then the helmet then attaches to this piece. All right, now let's talk about the helmet and how the water comes in. So this little hose piece right here, that attaches to the little piece that I just showed you that has the little blue disconnect. And the water comes in through the hose, up and around. We have it routed inside. It runs on the inside, and then it comes out through this little camelback bite valve. And so what you do is you bite on it. Not sure if you can see this, but it opens it up, you release it, and it seals it. And this works like a charm. So I've used this when I mountain bike, when I have a camelback water pack. Works like a charm. So we just adapted it. It rotates towards your mouth and away. Works like a charm. So that's the water. We're not going to touch it. It's one of those systems that's not broke, so we're not even going to try to fix it. Works like a charm. All right, so let me show you one more thing that we do to cool off as drivers. And it's a free, simple trick, but we need to improve it. So as you're driving along, gloves on, and you're going down a straight usually, you can put your hand out a little bit like this and cup the air and get the air to cool you down and kind of force it inside the cabin. It's surprising how well that works, especially at speed. Challenge is, especially for Alec, who has a little bit shorter arms, his arms goes like here and he can't reach out. And so I want to build something that forces the air in all the time through maybe a little external vent. And I'll walk you through that design thinking and that design process here in a minute. All right, guys, now let's talk about some of the improvements we're looking to make to cool us down better. So the first idea is, how do we get more air to our helmets? So really, step one is minimize any flow disruptions. Let me walk you through some of the areas that we've identified. So we've got this little piece right here that's just a little adapter piece. And you can kind of see it's a little janky, quite frankly, and it's hose clamped in. It's not awesome. So I'm going to design and build a little 3 to 1¼ inch adapter that has much better flow in. We're going to get rid of these white pieces too. These white hoses were okay, but they're a little rigid, a little cheap. I think I'm losing some cooling out of it as well. So we're going to go with a better style hose. And then we're going to get rid of this spaghetti. This is kind of ridiculous how much hose we're using here. So we're going to build some adapters down here on these little PVC adapters, and then have this little piece built out. And really that'll keep the flow coming in. We'll minimize the hose length coming in. So much better flow in, much better flow out. We're going to replace this hose with a much better quality hose up to our helmet. And then I'll show you an idea that we're thinking about for the helmet as well. All right, guys, let's talk about how the hose actually attaches to the helmet. We've got an idea on how to improve that as well. So this is our current hose, that white hose that was in the car. Again, it's a little janky. It worked, but there's an improvement here. The way that this actually attaches, there's these little barbs, and it's just a friction fit. And it actually worked pretty well. It was hard to pull off. But what was difficult about this is when you were doing this by yourself, you were trying to do it above your head and kind of fish it in, and it was difficult, especially with gloves. And where this really came into play was during our longer endurance race pit stops. They're timed, but you only have 5 minutes, and there's a lot to do in 5 minutes. And so what we want to do is we want to minimize the struggle here, because we saw a few times in races we were struggling to get this on here, and it just chewed up time. So there's an idea that we have that not only will make this easier, but the flow into the helmet should be a lot better. And we'll show you some ideas here in a minute. All right, one final thought on the air cooling to our helmet that we're going to try. Currently what we use is we use these little almond milk containers. You can just use any type of container that looks like this, like old school milk containers. And we freeze this, and then when we get to the track, we have a bunch of these in a cooler. We cut it open, and we take those blocks, we put the blocks inside the cooler that has some water in it. And we've just been using just these guys. What we're going to try this year, and we'll see if it works even better, is we're going to use a few more of these, and then we're going to take cube ice and pack it inside here with some water. And hopefully this will give some longevity to the ice, so it'll be around, and then the packed ice will get up and underneath everything and hopefully cool all that down. So again, it's a little thing that we're going to try out later this year. All right, so the last part is an improvement maybe to the helmet itself on getting more air in. So again, the way that this works is the hose comes in, air goes into this plenum piece, this black piece. And if you can see it, there's 3 little holes that we talked about that are drilled into the actual shell from the factory. There's one there, there's one here, and there's one here. And those drop in. It's a little hard to see, but hopefully you can see there's 3 holes. There's one down there, and then there's 2 on either side. And what we're going to do is we're going to open up this foam a little bit, this expanded foam. You can see some of the lines that we've drawn on here. And I'm just going to open that up a little bit to create some grooves. And hopefully that gets just a little bit more airflow to our head. So we'll see how that works. All right, so the next big idea that we have, and this may be complete ambitious but rubbish territory, but we're going to try to use some dry ice to cool us down. Here's the thinking. So we're going to use both of these hoses. We're actually going to disconnect it from the blower. And so the blower will just pull from inside air. We're going to take this end and that end, and we're going to try to build a contraption, basically, that pulls both of those into a little maybe T-fitting with a place you can put dry ice on the inside. So the air will come in, will come through, pick up that super cooled air, and then somehow we'll take another hose somewhere into the seat or over the seat. And we haven't quite figured that out yet, but that's idea number 2. All right, and the third idea that we're going to try, we talked about before, is how do we bring in some fresh air, some air without having to put your hand outside the car, outside the window here. So I'm thinking about designing a little piece that comes up, picks up the air kind of in this area, comes up, and over, and is in direct line with the steering wheel. So as your hand is on the steering wheel, you get constant air in and into the cabin. So again, a little design process. I'm not quite sure what that's going to look like or how we're going to attach it. But again, that's the fun of all of this, is that it's a iterative trial and error. So, we'll know if it works or not. And if it doesn't, then we'll tweak it and try to continue to get it better. And if it's absolute rubbish, then we'll scrap it and start over.